Okay, so hi everyone. I've only got a short time. I have to start going really quickly to get through everything. Be German, efficient. Right, okay. Who here has heard of dCache? A few hands. Who here hasn't heard of dCache? A few people. Okay, good. The next slide's going to be boring if you've all heard of dCache before. Here is basically what the entire talk condensed into one slide. We've got at DAISY, we have currently an own cloud instance. It's deliberately xCloud here. And we've taken this, instead of having a file system, we've got this big cloud here called dCache. And for people who have not heard of dCache before, this is some words you can use to describe dCache. Following Frank's earlier comment, dCache is a storage system that goes from running on a Raspberry Pi up to around 25 petabyte storage size. So it's nice to be in the select software out there that actually scales and that scale. We have instances tens of petabytes up to hundreds of millions of files. We're open source. You can download it now. You can install it. And people have been doing that throughout the world for over 15 years, so we're kind of hardened. The thing we've been working on most recently, however, is a thing called quality of service, which I'll be going into more details about that quicker than I thought. So it's about what the user experiences, what the user expects to happen, and what's actually happening, and how you can marry these two things together. We've been through the Horizon 2020 funding. We've been part of this Indigo Data Cloud project, which has been working in quality of service about standardizing it, standardizing how you describe it, standardizing how you access it and describe and tell the storage system what you want it to do, and working within dCache itself to provide users with more options and more flexibility. Okay, I'll move on. So currently what you have out of the box now, you have quality of service in terms of media locality. You can have a single copy on something, which could be a disk, but it's more often a RAID system. You can have redundant copies, where you have those redundant copies on different racks, different buildings, different campuses, different countries. And you can have a disk and tape copy, or disk and multiple tape copies, whatever you want there in that direction. So those are some quite useful choices. The one thing that we've added recently with the most recent version of dCache we've released is support for Ceph. And one thing I should sort of try to emphasize is that dCache itself is the distributed storage system. It doesn't use a distributed storage system. It is the distributed storage system. It has its own namespace. It's a complete system by itself. But people wanted to use Ceph for doing some of the data management stuff, so we thought, okay, fine, we'll add support for that as well. At the moment, it's a non-redundant system, so you have one Ceph pool, then you have a single access node for that one Ceph pool, but we're working on adding support for redundant systems, and that work would actually benefit people who are using a distributed file system with dCache. You can use it, you don't have to. Good. I have here an example. Does that graphic come out? Yeah, kind of. The quite shocking color of green here is a person who's sort of working at this campus one. And this is a fictitious example, but it's to sort of illustrate some of the things you can do with dCache, which are kind of cool. We've got an xCloud cluster here, which is sharing database, but they are NFS mounting dCache. So this is one dCache instance spanning, let's call this one Ireland, and this one here, the Netherlands. Just random choices based on the colors. And yeah, okay, good. And so this user here is reading and writing files, synchronizing files, and it's using this particular bit of dCache here. Likewise, this user here is reading and writing, synchronizing files, using this particular storage node here, part of a combined dCache cluster. And then the user says, I want to share this file with this guy over here in Netherlands. And then at this point, we can either, so this user starts reading the file, and dCache will internally make a copy of that file, if you want so. That then means that if you have multiple devices reading, they're all accessing the local file. It's good for synchronization. But we can even do this preemptively. We can say, well, this guy wants to share a file with somebody else. Most likely, that other person will want to read that file. So therefore, it makes sense to copy that file in the background as soon as they say it, they want to share it. So we have an extra copy over here. And this acts as a cache for this data. And so we can do that transparently in the background. And then this user, when they open their browser the next day, or their sync client starts synchronizing, it'll see the file locally, and everything will be fast. So just an example of the sort of things you can do with dCache. What are we doing? So I presented this model, the DAISY model of having OwnCloud in front of, on top of dCache last year in the Zurich meeting. So over the past year, we've been working on basically on three things here. So we've been looking at the NFS semantics here, where are places where the way the client is expecting the file system to behave isn't exactly what dCache was doing. And the most concrete example of that is when file was being updated, OwnCloud as it was there, is truncating the file and writing fresh data in. dCache itself is an immutable file system. This is a file system where once you close the file after writing it, you can't modify it. You can overwrite it with fresh data, with uploading to a new name and renaming it. That works fine. But you can't open it, you can't truncate it. Until now. We've added that support into dCache specifically, or at least the version that we have for OwnCloud. We've added this truncate option so that OwnCloud will work well with dCache, or work better. The other thing we've been having over the past year is a number of issues with networking being a little bit flaky sometimes, servers being a little bit flaky sometimes. And as a result of this, the steady state assumption, everything's up and running, that we found a few places where our recovery procedures weren't quite up to scratch, and we improved them so that it's now more reliable under real life circumstances. And the third thing that is big coming in the latest version of dCache is the high availability option. So with this, the core components of dCache you can now deploy those in a high availability mode, so that it'll do load balancing, and it'll do the ability for the upgrades and hardware interventions on that machine without downtime, without the users being affected. So that's available now in the latest version of dCache. Okay. So looking to the forward to the future, what I showed you as the first slide is only really half the story, or a fraction of the story, maybe not even half. The point about sync and share is integrating it with the applications. That's the key part, because the storage by itself is just storage. That's the next level, is the integration in the applications. And this we have within dCache as this kind of view, this vision of dCache being integrated in different ways to different systems. So we have our fast data ingest happening here over NFS here. Similarly, we have HPC clusters and grid clusters, which are similarly NFS mounting dCache, so they have the access to the data straight away. We have remote access here for people that want to view the files. We also have FTP for bulk transfer. It's another important aspect of large amounts when you have large amounts of scientific data. So we see dCache not as a sync and share solution, although it does fulfill that role, but or complements xCloud in fulfilling that role, but rather as part of a bigger picture where all parts of a scientific workflow, the data lifecycle, are covered. So this is really the vision that we have for dCache. And Peter, a colleague from DAISY, is going to talk more about some use cases tomorrow involving this kind of activity. So, following on from the previous speaker, you may notice the problem here we have with this picture, which is that the cloud front end here stores information about shares, duplicates the database that duplicates the namespace information that dCache holds itself. So we want to solve this problem, and we're actually following the first solution that Jon presented, which is moving information into the namespace, in this case, the dCache namespace. And what we want to do is introduce, what is suggested on, I think, the last slide, was introduce sharing, not as ACLs in our case, but as a concrete object, a new kind of object in the namespace. So you've got files, you've got directories, you've got symbolic links, you've got, if you like, you have hard links as well, but we're introducing a new concept, which is a share. And a share acts a bit like a magic door, which lets you into another part of the namespace. It's a bit like a hard link in how it works, but a bit different. So the share is owned by the person. It is that person can then rename it. That person can move it, can delete it if they want to. All of that happens transparently or independently of the original source file. Similarly, the person who's sharing the file can rename it and move it, all without affecting the share here. And if the person deletes this file, all the shares disappear here as well. So this makes shares a first-class citizen within the namespace. Similarly, we'd have shares as operating on directories, where somebody would share a directory, and that would then pop up in the person's home directory, and you would then have access to that directory through the share, through this magic door share. Okay, do I have confused looks on people's faces, or? No, magic is wonderful. Good. So this is really just to finalize the best of the rest. How much time have I got left? Is it 5 minutes? 5 minutes. Oh gosh, I'm going too fast. Quality of service has been the thing that we were most focused on within dCache at the moment. This is about previously with the quality of service in dCache. You have that. It's mostly configured by the admin, and it's at the directory level. So this is useful. Still within Sync and Share, you can give different users different qualities of service. So your students could get a single copy of a data file, or 2 copies redundant, and your professor or a very, very important professor can get 5 copies replicated, or one on disk, 1 on tape, so on and so on. You can even expose that to the users. You can tell the users, here is a directory called important. Put your important data in here, and it'll get backed up really carefully on disk and tape. The stuff that you don't care about so much, that can be stored on tape, but the disk copy is not guaranteed. It might be slow. That you can have on an archive directory, and then they write into that, and you give the users the opportunity to choose what quality of service they have. But that's on a directory by directory basis. And what we've been working on within the Indigo Data Cloud project is pushing that decision more towards the user, so they can choose on a file-by-file basis. I want this file to be when you first upload data, you don't know whether it's important or not, and then you sift through it, you discover, okay, this is the data that's important, and you then make some more analysis, and you then publish, and then that data becomes very important because you have to preserve it for a certain, publication requirements requires you to preserve the data for a certain period of time. So you can then, over the lifetime of the data, you can change the quality of service you want. And that's something we're working on through the Indigo Data Cloud project, funded through Horizon 2020. And part of that is actually being able to say what your expectations are on storage in a standard way that makes sense between different systems. So different people have different words for the same concept, and sometimes the same concept's described in different ways in different storage systems. So in order to sort of level this out, within the Indigo project, we've been standardizing what different things mean. So if you want a particular quality of service, then you can use the standardized terms and get that, and you know what you're getting, and less likely to be surprised. We're increasing the number of possibilities. As I said, we're putting in, making this a per file rather than a per directory basis. And we want to expose this to our sync and share front end by we already have a RESTful interface for describing and controlling quality of service, and we want to then expose this to users through the standard UI with an application. And I think that's where I'll stop. Just summarizing what I've said. Thanks. Yeah.
Excellent routine.
Yeah.
Thank you, you got me there. Plenty of time for questions.
Yes. Do you want the longer version or the shorter version? Okay, so yes, version 3, namespace only. NFS 4, 4041, 41 PNFS is I/O and also, well, namespace and I/O. So if you remount dCache, you get the namespace, so you can rename files, you can delete files, but you can't look at the content of a file. You can't write new files. SMB. We haven't had the users that have wanted it so far. So the dCache comes from the high-energy particle physics community, which are Linux boxes, at least within my lifetime. So it's the emphasis has been on Unix, Linux clients, and the big thing for us was the move from proprietary protocols towards NFS 4.1 PNFS for reasons I can spend another 10 minutes describing, but yeah, that's kind of the reason we don't have SMB at the moment.
Any further questions? I'll give myself a bit of time. Could I make the observation that your talk, as well as I think Ewan's talk, as well as I think what you'll be talking about, in part, is a request almost to have a sync and share service that really is just a front end and will trust your file store or whatever it is to be the authoritative source for metadata moving forward. And the fact that what you're doing is you're finding yourself replicating this data into databases is hindering rather than helping. And if you had a front end that would actually allow you to talk to some form of API or some form of abstraction layer, that would make your life a lot easier, wouldn't it?
Yes, I mean, it's
curveball question.
So it's a little bit ironic, actually, because, as I said, dCache is the storage system. It is the namespace, and our namespace is a database.
Precisely. Yeah.
So questions like, what is the path corresponding to this ID? Yes, it's a slow query, but for us, it's looking up IDs in a database rather than, and walking the file tree backwards. It's not as in with a normal file system where you're scanning the entire thing. So for us, we benefit because we can sort of get underneath the hood because it's our database. So certain things we can do in a much more optimal way than you can on a normal file system. But likewise, you still have the benefits because it's still structured similarly to a file system. We still have the benefits of being able to minimize the overheads involved. So it's for us, having the duplication really doesn't make any sense because we already have this optimized namespace implementation already. So using that is clearly for us anyway, is clearly the right way forward.
Yeah, it's funny to see that there are multiple implementations, multiple incarnations almost of exactly the same use case, except on different rich file systems.
Yeah.
I think we'll have another one here, won't we?